Okay, so we're going to take a look. Let's take a look at number 1. That is just your basic, when did you learn to do fractions? Elementary school?
Yes.
How did you learn how to multiply fractions? You multiplied straight across, right? You multiply across, right? So you went over here and you did that 3 times the 5 in your numerator. And then you went down and you did that 4 times the 7, right? And then you multiplied them. So you ended up with a 15 over 28. Okay? It doesn't like my 8. There we go. Okay? So we're going to come over to our rational expression. We're going to do the exact same thing. All right? We're going to multiply across. All right, so we're going to take that 2 times the x, which would give us what? 2x. And we're going to multiply the denominator. So in actuality, what we have are 2 binomials. How are we going to multiply those? What's our method? FOIL. We're going to have to multiply this thing by FOIL. So let's start with our first. So that would be our x times our x. X squared. Now let's take the outside and inside. So outside first. X times the 1. 1x. And let's take the inside. The negative 4 times x. Like terms, combine them. What's that give you?
Negative 3.
Negative 3x. You agree?
Yeah.
Okay. And then your last. That's going to be your negative 4 and positive 1. Negative 4. Okay. And so you multiplied across. All right. Any questions on that?
If you don't simplify or do nothing, that's just your answer.
That's your answer. Okay. All right, let's look at our second one. Number 2. We have 2 times a 4/9. What did you learn to do with that whole number?
Put over 1.
Put over 1, right? So we put whole numbers over 1. Let's change colors. So we would rewrite this as 2 over 1 times that 4/9. Okay? And then you would do just like we did on number 1. You multiplied that thing across. So you would take the 2 times 4 to give yourself an 8 over 1 times 9.
8 over 9.
Which would be 9. 8 over 9, yes. Okay. So let's come over here to our rational expressions. We're going to do the same thing. So that 3, that whole number of 3, we're just going to take that and put it over 1. So now you know where the 3 is. 3 is going to be multiplied with what? 8. So that would give you a 24 over the 1 times the x plus 6, which would just be, yes, x plus 6. Okay? Now let's take the second example we have there. We have an x plus 1. We still want to put that over 1. So we would still put that over 1 because we still need to establish that that is in our numerator. How are you going to multiply an x plus 1 times 8?
8x plus 6.
Distribute it, right. So that's going to give you 8x plus 8 over where's x plus 6. He's still being multiplied with a 1, so he's not changing. Okay? Let's look at 3. Does 3 look a little familiar? Did we? Yeah.
Yeah, I give you 30.
Deja, you have a question? Deja, you have an example 2. This one right here, the 8x plus 8. No, since we just went ahead and multiplied it out. We're going to leave it like that. All right, yes, number 3. What'd you say, Emily? Yeah, do you already see a common factor or a special one? Yeah. Yeah, what is it?
1 over 4.
The 4. So actually we can go ahead and cancel out first. So we can simplify sometimes before we multiply. So then that would make this pretty easy. Those 4s went to 1. And when we multiply out, all we have left in the numerator is 1. And denominator will just be the 9. So come over here to your rational expression. Do you see a common factor here?
Yes. X plus 3.
Yeah, those x plus 3's, right? We can go ahead and cancel them out. They'll go to 1. So what are you going to have left in your numerator?
2x.
2x.
X.
4x minus 1. Maybe. Okay, hold on. There we go. Okay, moving on. Question 4. What? We have a 4/15 times a 5/6. Can we what?
15.
Can we do some reducing this time maybe?
Yes.
Yeah, yes, very good. You have the 5 and 15 you can reduce. That would become 1 and that would become 3. The 4 and the 6,
2 and 3.
2 and 3. So again, you can reduce or simplify before you multiply. Okay? So let's come over to this rational expression. If you take a look at this, you see that you have a quadratic that needs to be factored. Okay, so we'll do that first before we multiply. And we also have, I think, a greatest common factor here. All right, so we'll do that first. So let's take the x squared plus 9x plus 20. Let's use our x method. It's not gonna, hold on, get rid of it. So we have our x. Okay, you need the factors of 20 that add up to 9. What'd you get? 5 and 4.
Oh, you do that because it equals 9?
Yes,
Okay.
out of room. There we go. Okay. What about that 2x minus 6? We've got a greatest common factor of 2. We're going to go ahead and factor that out. And that would leave us with x minus 3. Okay, so now what we're going to do is we're going to take a look at our factors, and we're going to look to see if we can do any canceling like we did over here before we decide to multiply. Kendall?
Where did that 20 go?
It's in here. 5 times 4 is 20.
Oh, and then 5 plus. Oh, okay.
And then 5 plus 4 is the 9. Okay. All right. Can anybody see a greatest, or can anybody see a factor? X minus 3's. Yes, ma'am. Those can go out.
And the x plus 5.
And they would become 1s. And the x plus 5's will go. They become 1s.
So it's 1 over x plus 4?
No.
X plus 4 and what else? 2.
Oh.
So we'll do 2 and then times the x plus 4.
Why is it times 2x?
Because the 2 didn't get crossed out. Just
The 2's still there. The 2 didn't get crossed out. So the 2 is still there in your second term. Your x plus 4 is still there in the first term. So now, depending on, again, to me this is simplified form, but you could then take that 2 and multiply it back in, and that would give you the 2x plus the 8, which is like that one you had, right, on the clickers. Okay? All right. Any questions on that multiplication?
Nope.
Okay. All right. Now, what's different about 5?
We're dividing.
Now we're getting into our division. How'd you learn how to divide fractions?
Flip the second one
And then multiply. What's the official name for flipping that? Reciprocal.
Reciprocal.
All right. So we take. Do it again.
So so we do 2 over 3
So-
and then 8 over 1?
No. Yes.
Okay.
So we take the reciprocal and multiply. We always take the reciprocal of the second one, right? We leave the first one as is. So to rewrite number 5, you would rewrite that as what? 2/3.
Over 8 over
2/3 times 8 over 1.
So 16.
And then you're back to, I don't see any canceling, so then go straight across, so that would give you 16 over 3.
You can,
Did I do that right?
Yes, ma'am.
Okay.
Oh, no, you can't.
What?
You can't simplify that, my bad.
All right, let's come over and look at our rational expression. We're going to do the exact same thing, right? Division is the same as multiplying by the reciprocal. So if we rewrite this, we would have 2x plus 4 over x plus 3 times what?
X minus 2 over 5.
X minus 2 over 5, exactly. Now, I'm looking at that 2x plus 4. Could we essentially factor a 2 out of that? If we factored a 2 out of that, that would leave us with an x plus 2. Would that help us cancel?
No,
Yeah.
it's not across.
Yeah, because there's not an x plus 2 in the denominator or a free 2. There's a 5 down there. So we're going to leave that as is, and then we could then go ahead and multiply straight across. So we would multiply the 2x plus 4 times the x minus 2. Again, we would have to use our what method? FOIL.
Would that be 2x squared?
Yes, so 2x times x, I'm going to put it above it, would be 2x squared. Now let's take our outside. The 2x and negative 2 would be
-4.
negative 4x.
And then
And
positive,
your-
so those are going to
Yeah, and your inside would be 4x, so those guys are out, right? They cancel each other out.
So it just leaves you with 2x.
2x squared, and then do your last, 4 times negative 2.
So 2x squared minus 8 over.
Yes, 2x squared minus 8. I am out of, I'm going to take that negative 4 off of there, so, that 4x off. So I might that smaller. So we ended up with 2x squared minus 8, right?
Yes, ma'am.
And the denominator, we have x plus 3 times 5. How are you going to multiply those out?
Distribute.
Distribute,
5x
exactly.
plus 15.
5x plus 15.
Oh, heck.
I'm going to do it over here. So we ended up with 2x squared minus 8 over 5x plus 15. All right? Any questions on that one? Okay. Let's look at our last one. Wait. No, hold on. Not until we're done. We're about done. Okay, number 6.
2x squared.
How are we going to rewrite that one?
Flip the 8 over 1 and then you can simplify.
So 8 over 1. Now, can we do anything?
We can simplify.
Okay, once we take the reciprocal, then we can now reduce before we multiply, okay? So I want to see how to word that. Once we change to multiplication, we can simplify. So in this case, which two numbers are you going to simplify?
The 2 and the 8.
The 2 and the 8. So 2 would become 1 and 8 would become 4. So that would leave you with 3 times 4, which would be 12 over 1. So that would just be what, 12?
12.
Yeah, 12 over 1. Okay, so let's come over here and see what we can do with our rational expression. See what we can do with our rational expression. So we would have that 4 over the x plus 3 times. Okay, now, what's going to go in the numerator is going to be this quadratic, x squared plus 4x plus 3. You know you're going to go ahead and factor it, so let's just factor it when we bring it up into its two binomials, okay? So we have x squared, so that would be our x and x. we have a plus 3 and a plus 4. So the factors of 3 that add up to 4. 3 and 1. So plus 3 and plus 1. And our x minus 7 now is our new denominator. So let's put him in.
Can you cancel out the x 3?
Can we cancel out the x plus 3?
Yeah.
Yeah, we sure can. Absolutely. So the x plus 3's go. Anything else? That's it. Okay. So 4 times the x plus 1 would be what?
4
X plus 4.
Over X minus 7.
Over x minus 7. Okay? So those are 6 different scenarios that you will see when you multiply and divide your rationals. So let's do a little summation. Remember, when can you simplify a fraction or an algebraic expression? When do we simplify? When we have a common factor in numerator and denominator, right? So we could say, when can we simplify? When we have a common factor. And what else? Let's talk about this last one here. What did we do after we changed it to multiplication? Then we simplify, okay? So remember, you can only simplify when it is in multiplication format, okay? Okay? If you try to simplify something and you still have your division, you're going to get it wrong, right? Because essentially you did not take that reciprocal to multiply. Okay? Any questions on that? All right, let's try a couple before we leave. Okay, so the 3 and the 9, 3 would become 1, 9 would become 3, and 2 would become 1, and 10 would become 5. So for our coefficients, in our numerator we have 1 times 5, which is 5, and the denominator we have 1 times 3, which is 3. Okay? Now we're going to go back and we're going to do the x's and the y's. So we're going to do the x's here. You have x to the 5th divided by x to the 3rd. That would be what? X squared. Bring that down. Okay. And then over here, x cubed divided by x squared. X. So we'll bring that x down. Now let's do the y's. Y cubed over y to the 7th. Y to the negative 4. So where's your leftover y's? In the denominator, right?
So y is going to always go on the bottom?
Not always, but it does in this case because you had 3 here and 7. The 4 extra ones are going to be in the denominator, right? So we will put him in the denominator. Like that. Okay, over here, these y's. Y to the 4th over y to the 5th. Y to the negative 1, so the extra y is going to be on the bottom. So down here. So let's bring all that together. The x squared times the x cubed over the 3. Now, the y to the 4th times the y. Y to the 5th. Right? 4 plus, what's that power? 1. 4 plus 1 is y to the 5th. Uh-huh.
So wait, are the x's going to always go on top and the y's going to always go
No.
on top?
It